We all experience time. It's an ever-present part of our lives, something we constantly measure and observe. It's that constant flow that takes us from one moment to the next, an unending stream that we can never pause or rewind. From the past, through the present and into the future, time is the thread that weaves the fabric of our existence. But what exactly is it? Is it just a human construct, or does it have a deeper, more intrinsic nature? How do we define something so fundamental to our existence? Is it merely a way to keep track of events, or is it something more profound? Time can be seen as a measure of change. It's the way we observe the transformation of the world around us. It's how we track the movement of the Earth, the rotation of our planet, and the cycles of the cosmos. It's also the beat of our hearts, the rhythm of life itself, and the inevitable aging process that we all undergo. We use seconds, minutes, hours, and years to organize our lives and understand the world around us. These units help us plan, remember, and anticipate. But time isn't just about clocks and calendars. It's a concept that transcends mere measurement. It's a deep concept that has puzzled philosophers and scientists for centuries. From Aristotle to Einstein, great minds have pondered its nature. The more we delve into the mysteries of time, the more fascinating it becomes. Is it linear, cyclical, or something else entirely? Let's embark on a journey to unravel its secrets. Together, we'll explore the many dimensions of time, from the scientific to the philosophical, and discover how it shapes our reality. Our ancestors observed the cycles of nature, the rising and setting sun, the changing seasons, the phases of the moon. These cycles became the foundation of early calendars and our understanding of time. Ancient cultures often viewed time as cyclical. Think of the ancient Mayan calendar or the Hindu concept of yugas, vast epochs of time. For them, time wasn't linear, but rather a repeating pattern. The ancient Greeks, like Aristotle, saw time as linear. Aristotle believed time was infinite and connected to motion. His ideas influenced Western thought for centuries. Isaac Newton, in the 17th century, gave us classical mechanics. His groundbreaking work laid the foundation for our understanding of the physical world. Newton's laws of motion and universal gravitation described how objects move and interact, providing a framework that scientists used for centuries. He described time as absolute and unchanging, flowing at the same rate for everyone, everywhere. This concept of time was intuitive and aligned with our everyday experiences, where seconds, minutes, and hours tick away uniformly. This view resonated with our everyday experience. People went about their lives confident that time was a constant, unaltered by their actions or surroundings. The predictability of time was a cornerstone of daily life and scientific inquiry. Then came Albert Einstein in the 20th century. His curiosity and innovative thinking led to a paradigm shift in our understanding of the universe. Einstein's theories challenged the established notions of time and space. His theory of relativity revolutionized our understanding of time. Einstein proposed that time is not a constant but a variable that can change depending on speed and gravity. This was a radical departure from Newtonian physics. Einstein showed that time isn't absolute but relative. He introduced the idea that time can stretch and contract, influenced by the velocity of an object and the gravitational forces it experiences. It's woven together with space to form a four-dimensional fabric called space-time. This fabric can be bent and warped by massive objects, altering the flow of time and the path of objects moving through it. According to Einstein, gravity affects time. The presence of a massive object, like a planet or a star, can distort space-time, causing time to slow down in its vicinity. The stronger the gravitational field, the slower time passes. This means that time moves differently depending on where you are in the universe, a concept that has profound implications for our understanding of reality. This phenomenon, known as time dilation, has been experimentally verified. Scientists have conducted numerous experiments, including those with atomic clocks on airplanes and satellites, confirming that time indeed slows down in stronger gravitational fields or at higher velocities. This discovery has opened new avenues in physics and cosmology, pushing the boundaries of human knowledge. Cosmology, the study of the universe, grapples with the concept of time on the grandest scale. It seeks to understand not just the physical properties of the cosmos, but also the very nature of time itself. How did time begin? How does it flow? And what might its ultimate fate be? The prevailing theory of the universe's origin is the Big Bang. This monumental event marks the beginning of time as we know it, a colossal explosion that set the universe into motion. It suggests that the universe began from an incredibly hot, dense state about 13.8 billion years ago. From that singularity, space itself started to expand, cooling and forming the galaxies, stars and planets we observe today. But what was there before the Big Bang? This question has puzzled scientists and philosophers alike for generations. Was there a time before time? Or did time itself begin with the Big Bang? Was there even a before? The concept of before may not even apply in the context of the Big Bang, as time itself might have been created in that very moment. Some theories propose a cyclical universe, where Big Bangs and big crunches occur in an endless loop. In this model, the universe expands, then contracts back to a singularity, only to explode again in another Big Bang. Others suggest the existence of a multiverse, where our universe is just one of many, each with its own timeline. In this scenario, different universes could have different laws of physics, and time might flow differently in each one. The mysteries of time and the universe continue to captivate and challenge our understanding, pushing the boundaries of science and imagination. Philosophers have long debated the nature of time. Is time a fundamental aspect of reality or simply a human construct? Does the past still exist? What about the future? Immanuel Kant, an 18th century philosopher, argued that time is a fundamental structure of human experience. We impose the concepts of past, present and future onto the world to make sense of it. Some philosophers, like J.M.E. McTaggart, have argued that time is an illusion. They point to paradoxes and inconsistencies in our understanding of time to support this view. Quantum mechanics, the physics of the very small, throws another wrench into our understanding of time. In the quantum realm, events don't always happen in a linear, predictable way. Particles can exist in multiple states at once, and the act of observation seems to influence the outcome of events. Some interpretations of quantum mechanics suggest that time might not be fundamental, but rather emerge from a more fundamental reality. The mysteries of quantum mechanics challenge our intuitions about time and raise profound questions about the nature of reality. Time travel, a staple of science fiction, captures our imaginations. But is it physically possible? Einstein's theory of relativity doesn't rule out time travel, but it does present significant challenges. One challenge is the existence of time paradoxes. Imagine traveling back in time and accidentally preventing your parents from meeting. Would you cease to exist? While time travel to the past remains highly speculative, time dilation, a consequence of relativity, offers a glimpse into the malleable nature of time. Despite its complexities, time plays a crucial role in our daily lives. We rely on clocks to synchronize our schedules, calendars to plan our days, and historical records to understand the past. Our perception of time also shapes our experiences. Time seems to fly by when we're having fun, but drags on when we're bored. Our emotional state and surroundings can influence our subjective experience of time. Understanding the nuances of time management and time perception can be essential for productivity, well-being, and making the most of our finite time on this planet. Despite centuries of inquiry, time remains one of the most profound mysteries in science and philosophy. We've made remarkable strides in understanding its nature, but many questions linger. What is the true nature of time? Is time travel possible, and if so, what are the implications? Can we reconcile our classical understanding of time with the strangeness of quantum mechanics? These questions continue to drive scientific exploration and philosophical debate, pushing the boundaries of our knowledge and challenging us to rethink our place in the cosmos. Time is a concept that touches every aspect of our lives. It's a fundamental aspect of the universe we inhabit, yet it remains deeply mysterious. What are your thoughts on the nature of time? Do you have any theories or questions you'd like to share? Let's keep the conversation going, share your perspectives, and join the quest to unravel the enigmatic nature of time.